This video is all about Unit 1 of DLD. The first concept that we are going to learn here is about logic gates. I request everyone to pay attention here because this is the primary and basic concept which makes you very clear and easy about DLD. So the first thing that you make to clear is about this concept. Okay, so basically logic gates are divided into three types. Let me discuss each one individually. Okay, so now the first type of gate is AND gate. Okay, so first let's discuss about AND gate and then we will go with OR gate and NOT gate. First let me go with the representation of AND gate. So here in the AND gate we will have two inputs to be taken. One is A and another one is B. And this is the representation of AND gate, and by using this we will get the output C. In a shorter term, the representation can be C equals to A dot B. Okay, so this is the representation. Now let me walk you through the truth table, okay, which is another important part here. Okay, so please check here carefully as we are taking two inputs. Okay, we are taking input A and input B. Both can have false and true. That means here in DLD, true is denoted with 1 and false is denoted with 0 for your easy understanding. Okay, so if each of the input have one true and one false value, how many combinations we can have? That is 2 power 2, right? That is 4. We will have 4 combinations here. Okay, so let me draw the truth table by considering this things. Okay, so here I'm taking A input, I'm taking B input, and I'm writing the output C equals to A dot B. Okay, so here first let me take the inputs. I told you that it will have one input, like one true and one false. So true is denoted with 1 and false is denoted with 0. Okay, similarly this also will have one input, one true and one false. Now as we are thinking about the combinations, we will go with 1 0 as well as 0 1. Okay, see here the thing that you need to notice here is we are doing multiplication. Strongly remember that C equals to A dot B, so dot means multiplication. Think like that. Okay, so here when C equals to A dot B, when it is multiplication, so 1 into 1 1, 0 into 0 1 into 0 0 into 1 0, right? So this is the truth table for AND gate. And don't worry, at the end of the session I will provide you this PDF also. What I'm writing on this board will be given as a PDF. Okay, you can check that also. Now let me discuss about OR gate. That is the second type of gate. Okay, which is OR gate. Now here again we are taking two inputs, but first let's go with the representation of OR gate. Again I'm taking here two inputs, one is A and another one is B. A, B. Let me change the marker. Okay, I hope it is clear enough, right? So this is one representation and we are getting the output as C. Okay, so this is the representation. Now when you are taking this A, B and you are performing some operation here and you are getting C, so the operation can be represented here as C equals to A plus B. Remember, AND is for multiplication, OR is for addition. Okay, so this is the representation of OR gate, both with the formulae and also with the diagram. Now let's consider the truth table. Okay, coming to truth table, let me draw this Again we are taking two inputs, so for combination we'll have 4, right? We need to consider 4. So A, B, C equals to A plus B. Now again we are considering the possible combinations. Okay, you can write it anyway, but make sure that the 4 combinations are written. Now as it is plus 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 also will be 1. Okay, remember this, 1 plus 1 also will be 1. Okay, don't confuse and make it 2, it is 1 itself. Okay, so this is the thing that you need to learn about OR gate. Next, coming to the last type of gate, that is NOT gate. Okay, so in the word itself it is a complete opposite one. Okay, so let me explain you with the representation first. So here we are taking only one input, and this is the representation of NOT gate. So once you take this input, you are getting the output as B. So let me represent this with this. So here B equals to A bar or A dash, which represents the opposite of A. And as we are taking only one input can be taken, it has only one true and one false. As I told you, let's construct the truth table for this one thing. Okay, so as we are taking only one input A, the opposite one, the output will be B, which is B equals to A dash. So now I'm having one false and one true. So opposite of false will be true, opposite of true will be false, right? So this is about the 3 gates. Okay, and we also have some universal gates. Okay, so let's discuss about that also. Coming to universal gates, again we have 2 types of gates here in universal gates. Okay, so universal gates are NAND and NOR. Okay, have you seen this similarity here? Have you observed this? NAND means which is an opposite of AND. NOR, which is an opposite of OR. Got it? Yes. So now we will discuss this in detail. Okay, so first we will go with the representation of the NAND gate. Okay, so NAND gate, I told you, which is a complete opposite of AND, right? So here let's go back and check with the representation of AND gate. If you see, this is the representation of AND gate and it has a D shape, right? So now the representation of NAND will be like, you are taking 2 inputs again, like A and B, and the output, the NAND gate representation will be like, here you will have a NOT. Okay, so this will be the representation of NAND gate, remember. Okay, and now the representation is done, and now you have to also know about this. So we are taking AB whole dash, that means the complete opposite of this. Okay, now let me construct truth table so that it will be more easier for you to understand. Okay, whole dash, remember it's AB whole dash. Now we are constructing, as we have taken 2 inputs, there will be combinations of 4 possible combinations, right? 0 0 0 1 1 0 1 1, right? So now coming to C equals to AB whole dash. So as we discussed, it's dot, right? C for AND, A dot B, that is A multiplied B. So when A is multiplied B, and for NAND it is complete opposite, right? It is complete opposite, that is what you need to consider. So first let's go with 1 into 1. So 1 into 1 is 1, but as it is completely opposite, it should be 0. And 1 into 0 should be 0, but as it is NAND, that is opposite of AND, you will give here 1 1 1. Got it? So this is the truth table constructed for NAND gate. Similarly, let's discuss about NOR gate. Okay, I hope you are clear with this. Just compare this with AND gate. It will be more easier for you to remember. Okay, let's go with the second type of universal gate, which is NOR gate. Again, which is a complete opposite of OR gate. Let's have a look of OR gate. Here you can see the symbol for OR gate. So now here the circle will be represented for NOR. Okay, and NOT will be included. So let me draw. Here we are taking two inputs again, A and B, and the representation is this, right? And here we got a NOT, and here it will be C. Okay, and the representation for this is C equals to A plus B, as we thought NOR or is an addition, so the complete one bar. Okay, so it is a complete opposite of A plus B. Let me draw the truth table. As we are taking two inputs, how many possible combinations will be there? Exactly, there will be 4 combinations, right? So here we are taking A plus B whole dash, and the possible combinations are here. Now, according to us, 1 plus 1 will be 1, right? But here we have to make it as 0. 1 plus 0 is 1, but as it is NOR, we need to do opposite. And 0 plus 0 will be 0 actually, but as it is NOR, you have to give 1. So this is the truth table for NOR gate. Okay, and these are about gates that you need to know about. Okay, so these two are called as NAND and NOR are called as universal gates, and remaining are the basic gates that you need to remember. Okay, got it? Let me also explain you about the most bit confusing part, but it is very easy with my explanation, I guess. Let's also discuss about exclusive gates, okay, which are also very important. Okay, so please listen this carefully. Coming to exclusive gates, we have two types. One is XOR and another one is XNOR. Okay, so let's not compare with any gate. Let's divide it into individual gates itself. Okay, so that you will not confuse at all. So the first gate that we are going to discuss here is XOR. Okay, and let me show you representation. Okay, so the representation is, again you are taking two inputs A and B, and here this is the representation. Please make a note. Okay, and this is the representation, and the normal representation of this will be like A bar B plus A B bar, or this can also be further said as A plus B. There is a round for plus. Please note this point. Okay, so this is the representation for XOR. And let me go with the truth table so that you will never confuse. As we have two inputs, how many possibilities will be there? 4. Let me draw this truth table. A, B, and C will be like A plus B, or is addition, but it is XOR. Please make that point. Okay, now as I told you that we will have 4 possibilities, listen carefully. I'm writing all these possible things. Now please remember, for XOR, if they are having same type of inputs, then it will give the result as false, that is 0. Same inputs will give false and different will give true. That is how you need to note. Okay, and here the one more thing that I want to do is, don't remember both the things, remember only one thing. Either same inputs will give false or different outputs will give true, but don't remember both, you will get confused. So I prefer you to remember that same inputs will give false, same inputs will give false, that is 0, same inputs will give 0. Next we are talking about XNOR next. Okay, coming to the XNOR gate, let me show you the representation for XNOR gate first, then we will further go ahead. Okay, coming to XNOR gate, here there is a small thing that I need to note here, you people to note here is, here it is, this is the XOR gate, this is the representation of XOR gate, remember, and the representation for XNOR gate I will show it now. Okay, so now we will discuss about XNOR gate. So coming to this XNOR gate, again we will have two inputs AB, and the representation here is, you are having this arc and also this is being drawn, and here you will have a knot. So this is the representation for XNOR and this is the representation for XOR. Please make a note. Okay, so now the representation for this can be like C equals to AB plus AB bar. Okay, A bar B bar. So here A B, between we are multiplying the, like we are performing multiplication, or this can also be represented as A dot with circle B. Okay, so this is the representation for XOR gate. Now let me go with the truth table. Now here for XOR gate, could you please remember XOR gate specifications in the meantime? It is like for XOR, similar outputs will give you false, that is 0, right? Here I am writing once again the possible things. Now as we have XOR, we have same will give false. Here in XNOR, same outputs will give true and different will give false. Same output, same input will give you true. Okay, so this is the thing about XOR and XNOR gates.